We did look at the area formula and the circumference formula. We're going to use those again. Those are definitely some things to have memorized. And it says, what is the area of a circle whose circumference is 2 pi over 3? So we're going to start with their circumference formula because it's telling us their circumference. So I'm going to say we have 2 pi over 3. That's going to be equal, that's what C is, and that's going to be equal to 2 pi times r. So I'm going to solve for r. All I have to do is divide by 2 pi. So that's the same thing as multiplying by 2 over pi. Oh, great. Look at that. Isn't that beautiful? So 2 pi cancels out. And I'm just left with a 1/3. So I get to 1/3 here. And that equals to r. Great. Now I can use my area formula. I just plug in r, which is 1/3, right there. So area equals pi times r, which is 1/3. And I gotta square it. If I'm squaring a fraction, I just square the top and square the bottom, so it becomes 1/9. So it's pi times 1/9, which is the same thing as pi over 9. Great. Goodness gracious, that was easy. I'm gonna move on. So we used both the area and the circumference formula. We gotta have a good time, huh? You can go back and forth either way. Maybe they give you area first, so use that to find r. You'd have to divide by pi and then take the square root of both sides. And then if they are asking for the circumference after you've found r, you plug it into the circumference formula. It's doing the same steps. It's just solving for r in this one and using it in this one. So yeah, that's pretty easy. Okay, so I feel like people get scared with the ratio problems. So we're gonna do a ratio problem right here, right now. Look at this. Pay attention. You looking? You open your eyes. Let's look at this. So the figure's not drawn to scale. That's important to know. So maybe it's not so helpful. If the ratio of the measure of arc xy, so the measure of arc xy, I'm going to draw the center. Remember, the measure of this arc is different from the arc length. The measure is in like degrees. So remember, the measure of the arc is the same as this angle. So that's something to keep in mind. And then, so if the measure of that arc to the measure of yz, so the measure of that arc, so I draw that. Well, that's kind of nice. Nice. So the measure of xy, remember, we have two different arcs, and the way we measure the arc is by getting the angle from the center that intercepts that arc. So we got that, we got this. Okay, very good. To the measure of xz, so I'll do that in green. So the ratios of that is going to be 2 to 6 to 3. So this is going to be 2 to 6 to 3 there. What is the measure of angle x? What is the measure of this angle? And remember, at the very beginning I had something like this, where x was an inscribed angle. So if I figure out the measure of yz, which would be this, then I know that the measure of angle x is 1/2 this. So that's what I'm keeping in mind, and I'm going to figure out what the heck yz is, what the measure of yz is. So if I'm given a ratio like this, this is what I'm going to do. I know that the entire circle, look at that, I know the entire circle is 360 degrees, but I also know that, so this plus that has to equal 360 degrees. I just don't know what they are. But I know if I divided them, like if I did the measure of arc xy, that's the top one, divided by the measure of arc yz, I should get 2 over 6, because that's what it says, which is 1/3. And then for this one, for yz divided by xz, I should get 6 over 3. So I don't know what the actual angle measure is, but I know that when I do angle measure, I should say arc measure, which is in degrees, keep that in mind, I know that it reduces to this. So to unreduce, I'm going to multiply by x in all of them. So really, this, if I unreduced it to the proper amount, then the arc measure would be 2x. The arc measure would be 6x. 6x there, that's good. And then the arc measure would be 3x. So I don't know how much to unreduce it by, but there we have it. So now I have 2x plus, because 2x is going to represent this, plus 6x plus 3x, that's going to equal 360. I'm unreducing there. I know that when I do reduce it, it's got to equal 2/6, but I don't know what to unreduce it by. That's how I'm thinking of this, because they're given ratios that I have to use. So what is this? 6, 7, 8, 9, 10, 11 x equals 360. Divide by 11. Great, that doesn't work out nicely, but we have x equals 360 divided by 11, which is approximately 32.72. Actually, it's exactly that. So, great. Now I have, so that's the measure of this arc, and I know that now. Oh, no, that's not the measure of that arc. Is it not? It is not. I know what x is, so I know what to unreduce by. So to figure out what yz is, which is that, I need to use my 6x. Okay, so measure of arc yz will be that. So that's going to equal, so hopefully you understand what I'm plugging in there, because I didn't actually have the measure of the angle, I just had the factor which I'm unreducing by. And then, so times 6, and that's 196.36 repeating. So I have this measure, and remember from the first example, so this is like 196, this angle is half of that angle. So what I'm going to do is divide this by 2. So my answer for the measure of angle x, that's going to be 196 divided by 2. And it's again going to be a repeating decimal, 98.18. And that's going to be degrees. There we go. Beautiful, beautiful. That one's a complicated one, but hopefully you understand the ratio part once again. Good day.